Hello everyone, this is Anmol Gera and today we're going to discuss a very cool problem called LCA on binary search trees. Okay, so about the problem, we have a binary search tree and we have to find the lowest common ancestor of the two given nodes in the BST. So according to the definition of LCA, the lowest common ancestor is defined between two nodes P and Q such that the lowest node in T basically it should contain both the nodes P and Q and it should be the lowest. Like if we see the examples, let's suppose P is 2 and Q is 8, then the answer should be 6. Let's suppose if P is 7 and Q is 9, then the answer should be 8, not 6, because 8 is lower than 6. So we have to find that particular node which is the lowest common ancestor. As you know, like in Hindi, ancestor means purvaj. In Hindi it means that the things which are basically older, or yeah. So ancestor is that, and lowest means that immediate older. Matlab, if I have to basically tell who is the lowest common ancestor of me, so that would be my father. Who would be the lowest common ancestor of me and my sister? That would be my father, not my grandfather. That's the question. So yeah. Now how will we approach this? So since it is binary search tree, so we can, in case of binary search tree, we can always, more or less, we can always do log n time. The logic of binary search is simple, that if, let's suppose if you want to find a key, a particular key called k, and if k is greater than the current element, then we will go right. If the key is less than the current element, we'll go left, and if the key is equal to current element, we'll simply return that current element. That's how binary search usually works, and it works in log n. It works in all of log n time. The complexity is of log n. Okay, so what we have to do is we have to basically think of this problem as a binary search problem, like finding an element in a binary search, let's suppose in an array. So how will we do it? Okay, so the logic is, let me just make it. Okay, let's suppose if the value of root node is 3 and if the value of P and Q is 5 and 8, now treat 5 and 8 as one element. Let's suppose, yeah, if not one element, two elements. Let's suppose if 5 and 8 both are greater than 3, it means we should go to right. Let's suppose if it would have been only one element, only 5, so the logic is that we should move to right, and and check if we can do better. Yeah, so the same logic applies here. Let's suppose this was 3 and this was 5 and 8, and let's suppose this was 4. Now the value of P is 5, the value of Q is 8, and the value of root is 3, so we'll go to root right. Now why I'm saying is we should always go to root right, because why I'm saying this, because let's suppose if this was 5 and let's suppose this was 6, then also we should go to root right, right hand side of the tree. Why? Because we can always do better. In this particular problem, if both the nodes are greater than the root value, we can always do better by going in the right direction, because in this case 5 is a appropriate LCA. 5 would be the appropriate LCA. If we'll go to in the basically right direction, we'll go to 5, and 8 is here. This was 6. So 5 is an appropriate answer to this particular problem. If root value is equal to one of the values, then also it's fine. That particular node can be an LCA. Yeah. So similarly, if both the values of P and Q is less than root, if both the values of 1 and 2 is less than 3, then we should always go in the left direction, because we can always do better. By better I mean that we can find a more lower ancestor. By going towards the right side, I found 5, which is a lower ancestor than 3. Similarly, if by going in the left hand side, I can always find a better answer to my problem, better ancestor, a lower ancestor. That's what I mean by better. But what if, if these two are not the case? Let's suppose if one of the values is equal to root, then what would be the case? If one of the values is lower than root and other value is greater than root, let's suppose this is the case, then what would be the case? If it is 338, it simply means that that 3 is our LCA. Well, that particular in that case root is our LCA, and if any of the values is equal to the value of root, and if this is the case when p is less than 3 and n9 is greater than 3, in that case also the root is the answer. Let's suppose this was the tree. Now one is lower than 1, the value of 1 is lower than the value of 3, so 1 would be in the left hand side, and similarly 9 would be in the right hand side. So in that particular case 3 would be the lower most ancestor that we can do, because after this if we go to left hand side we cannot find 9, and if we go towards the right hand side we cannot find 1. So 3 is the lowest common ancestor. Yeah, so that is the whole logic. If both the values is greater than 3, we'll go towards the right side. If both the values is less than 3, we'll go towards left hand side. And if any of the condition is not true, if both of these conditions is not true, we'll simply return the root, because that would be our answer, LCA. So yeah, that is the logic. Now the code is pretty simple, so let me code it from start. It's not a very difficult job, I might be able to. Okay, so let's suppose let's calculate the parent value first. That would be simply, now since these are the addresses, not the value, so we have to basically first convert it into the data. Int c1 would be p value, the value of the node p. Similarly child 2 would be q value. Now according to our logic, if c1 is greater than parent and c2 is greater than parent, then we can always do better. By better I mean we can always find a more lower ancestor by going towards right. So just return this. That is a very loud sound, I must say. Okay, so this will be right. Yeah, right. ओके यार, समझ गया मैं, इतना गुस्सा क्यों हो रहा है. और else if c1 is less than parent and c2 is less than parent, then we'll go towards left. Or if the case is not, or else that particular root is our LCA, else return root. Here I have to return and here I have to return. Yeah, that is the logic. I think this should work. Yeah, so this is the code. Yeah, so I hope you understand the question. It's like a normal binary search, nothing different in particular. The only interesting case is when one of the values is lower than the root, another is greater than the root. Then in that case, that particular node is our LCA. Yeah, so thanks for watching and hope you have a good time. Thank you.